In this video, I want to find the integral of secant x dx. The integral of secant x dx is equal to the integral of secant x times the quantity secant x plus tangent x divided by secant x plus tangent x. It's a slick step to go from the first line to the second line, okay, for sure. And so what I did was I took secant x and essentially multiplied it by a form of 1, right? Because remember, when you take something and multiply by 1, you don't change its value. Now, to go from line 2 to line 3, I'm going to distribute the secant x to each term within the parentheses. And so I get the integral of secant squared x plus secant x tangent x divided by secant x plus tangent x dx. Now, to evaluate the integral on the third line, we can just do a u substitution. And so I'm going to let u equal secant x plus tangent x. du is secant x tangent x plus secant squared x, that quantity dx. Okay. Now from here, the integral of secant squared x plus secant x tangent x all over secant x plus tangent x dx is equal to the integral of 1 over u du. And so this is natural log of the absolute value of u plus c. But remember that u is equal to secant x plus tangent x. So when I substitute that in, I get natural log of the absolute value of secant x plus tangent x plus c. And then I'm done. So we can say the integral of secant x dx is equal to the natural log of the absolute value of secant x plus tangent x plus c. Now, I want to show you something. In this example, right, suppose we have the integral of secant cubed x dx. So the trick on this is I'm going to write this as the integral of secant x times secant squared x dx. And so this can be done by parts. And remember that secant squared x has a nice integral. Secant x, not so much. And so I'm going to let u be secant x. So dv is secant squared x dx. du is secant x tangent x dx. And v is equal to tangent x. So the integral of secant cubed x dx is equal to, it's going to be u times v, which is secant x tangent x, minus the integral of secant x tangent squared x dx. Now, let's make a note here. 1 plus tangent squared x is equal to secant squared x, right? So tangent squared x is equal to secant squared x minus 1. So from here, we can say the integral of secant cubed x dx is secant x tangent x minus the integral of secant x. And then what I'm going to do, let's go back. I'm going to replace tangent squared x with secant squared x minus 1. Okay. And so I get secant x times secant squared x minus 1 dx. So the integral of secant cubed x dx is secant x tangent x minus. Now, what I'm going to do is distribute that secant x to each term within the parentheses. And when I do, I get minus the integral of secant cubed x minus secant x, this whole thing dx. And the trick on this is you have to split up that integral. So the integral of secant cubed x dx is secant x tangent x minus the integral of secant cubed x dx plus the integral of secant x dx. So remember, a negative times a negative is a positive, which is why that sign ended up, that's why I ended up adding the integral of secant x dx. And so what I do from here, I'm going to add the integral of secant cubed x dx to both sides. So we cycle back to the integral of secant cubed x dx. And then what I get is the integral of secant cubed x dx, and remember this is times 2, is equal to secant x tangent x plus the integral of secant x dx. Divide both sides by 2. The integral of secant cubed x dx is 1/2 secant x tangent x plus half the integral of secant x dx. And then I'm done. The integral of secant cubed x dx. If you guys don't mind, can I pull that 1/2 out in front? And if I do, I get 1/2 the quantity secant x tangent x plus, and we just went through that trouble of integrating secant x dx, so we don't have to reinvent the wheel. We write natural log of the absolute value of secant x plus tangent x plus c. And that's going to conclude this video where we did the integral of secant x and the integral of secant cubed x dx. So in other words, with respect to x. Okay, thank you.